Okay, I'm going to do some examples of direct variation. Now, the words are going to be sometimes a little tricky. I might say there's a direct variation between two numbers. I might say varies directly. I might say directly proportional to. All of these mean the same thing. So first of all, you need to come up with a standard equation or a model equation for direct variation. And I have two forms of it. Y equals mx, very similar to the y equals mx plus b, and another form, y equals kx. M and k are what's called the constant of proportionality. And so those will vary as we change problems, but you start out first using this direct proportion equation. Now let me give you an example. Okay, so now I have an example here of a direct variation problem to solve. And again, these are the two direct variation equations that I can use. M is the constant in this case, K is the constant in this case. It doesn't really matter which one of those you use. And basically, there's a few simple steps in solving a problem like this. First of all, write an equation based on the first bit of information. So decide what you're going to use. I'm going to use y equals mx. So first bit of information says y is 25 when x is 15. So plug that in. 25 equals m times 15. I'm going to rewrite that as 25 equals 15m. All right, now it says find x when y is 40. So that gives us another piece of information, but what I have to do first is I have to solve this for m. So solving this for m, if 15m equals 25, m equals 25 over 15, and of course you need to reduce that, so 5/3. So m is my 5/3. m is 5/3. That's an important piece. Okay, now let's go back to this equation. I know the m, so instead of y equals mx, I can write y equals 5/3 x. Now I have a specific equation for this problem. Let's read the second part. Find x when y is 40. So, if y equals 40, let's plug it in. 40 equals 5/3 x. Now what do I do? Can you see that? All right, 40 equals 5/3 x. So solve it for x. Multiply both sides by 3 over 5. So 3 over 5 times 40 equals 3 over 5 times 5/3 x. Hopefully you see some nice reducing that can happen. 3 times 8 is 24. 1 times 1 times x is x. So x equals 24. And there's the solution. So basically, here are the steps. Decide on the equation, plug in and solve for m, and then use the m. So equation, solve for m, use m with the new information, and then solve again. Use those steps, you should be fine on this assignment. Good luck. So now I'm going to do an example using inverse variation or inversely proportional or constant of proportionality. Those three words mean the same thing. So y varies inversely as q. Y equals 22 when q is 6. Find q when y equals 15. So first of all, the big clue was inverse, so that means I need one of these three equations y equals m over x, y equals k over x. The constant can be m or k. Or sometimes people prefer to multiply both sides by x so that you don't have a fraction xy equals k. I'm going to use y equals k over x. So I choose the equation for the proper variation that I'm doing. Then I plug in the information from the first sentence. So y is 22 when q is 6. So, well, I guess I should say y equals k over q, shouldn't I, since they use q in this one. So, y equals k over q. Y is 22 when q is 6, so 22 equals k over 6. And then what I should do is let's solve this for k. So k equals, what's 22 times 6? I guess I need a little help here. 132? Is it 132? Yeah. Okay. Now, what do I do next? Put it in and write a new equation. So now I have a new equation with the constant. So y equals 132 over q. All right, directions. Find q when y equals 15. Let's plug it in. Y is 15. So 15 equals 132 over q. All right, let's solve this. Multiply both sides by q. So 15q equals 132. Q, let's divide by 15. Q equals 132 over 15. Can I leave it like that? I hope you said no, you need to reduce it. So again, just use your graphing calculator, plug in the numbers, and 132 over 15 reduces to 44 over 5. So the constant is, the Q is 44 over 5. And that's the final answer. So can you see that? Sorry about that. So Q is 44 over 5. I always run out of space on my board here. So you can try some of these. All right, here it goes with a complicated one that's got jointly and inversely and all kinds of things messed in. Z varies jointly. Z varies. So there's my clue. Z equals. Jointly as U, all right, I need a constant, so K times U times V, and inversely as W. Do I put times W? Oh, over W. Okay, there we go. Don't forget, when you write these equations, you have to add a K that's usually not in the given information. All right, now let's use all these numbers that they gave us and see if we can solve for K. So Z is 4/5. 4/5 equals, we don't know the K, that's what we're going to find. But I have a U, which is an 8. I have a V, which is a 6. And I have a W, that's hard to read, which is 5. Which is 5. Okay, now I need to solve this for K. Let's first of all multiply both sides by 5. That's an easy step, yeah? Okay, so now I have 4 equals K times 8 times 6. I know you could multiply these, but don't. Save it till the end because it's easier to solve with reducing. It makes you a quicker math student. All right, so let's keep going here. So now let's get the K by itself. So let's divide this side by 8 times 6 and this side by 8 times 6. Cancels out there. 4 goes into 8, 2. 2 times 6 is 12, so I have 1 over 12. So K is 1 over 12. All right. So this problem now is Z equals 1 over 12 times U times V all over W. There's my new equation. That's important find. Now find Z when U, V, and W are these numbers. So again, just plug them in. So do I have room here? So Z equals 1 over 12 times U, which is 3, V, which is 10, W, which is 5. Now, I could do 12 times 5 and 1 times 3 times 10, but you know my rule, reduce first. 5 into 10, 2, 3 into 12, 4. So Z equals 2/4, not a good answer, reduce it, 1/2. Z equals 1/2. So, jointly, with a big mix of crazy things in there. just write your equation. Don't forget to put in the constant, M or K, and then plug in the numbers to get your new equation, and then solve your new equation. You can do these.